Alright, so in this video we're building on our idea of solving inequalities in one variable like we did in the previous video, but this time we're talking about a new concept because we have more than one inequality in a single problem that we need to solve. And those are called compound inequalities. So a compound inequality is a simple inequality that's joined by the word and or. Think of it as Thanksgiving dinner. You go to your boyfriend or girlfriend's house for the first time. You don't want to be rude or anything, so if they have ham and turkey, you're happy, great, you have both. Or if they only have ham or turkey, you're not going to throw a fit and cause a scene. Ham is fine, makes you happy, or turkey is fine, makes you happy. Either way, you're not going to make a scene and make a big deal about it. So, for instance, let's talk about and problem first. And is essentially any inequality, any compound inequality, so we're going to have two inequality symbols where the variable is in the middle. This is an and problem. Okay? And what that means is we have two separate inequalities that we can solve. So what I like to do for this type of problem is actually split those up. So negative 2 is less than or equal to x, and x is less than 1. Now, when we graph these, we've got to be careful. We have to pay attention to both. So, what I'm going to do is first graph x less than 1. Well, since there's no line underneath that inequality symbol, I need an open circle at 1. And it says all numbers that are less than 1. So, I'm going to do this one in, let's say, yellow. And just shade on my number line. All numbers that are less than 1, so I need to pick a test point. 0 is less than 1, so that's true. So all numbers to the left will make that inequality true. And I'm going to do this inequality over here in purple. Now, for this inequality, what I'm looking for is x is bigger than or equal to negative 2. So first off, at negative 2, I need a closed circle, which means negative 2 is part of my graph. And then what I need to do is find the numbers on my number line that make this inequality true. So x is bigger than or equal to negative 2. So again, I like to use 0 as my test point. 0 is bigger than or equal to negative 2. So all these points to the right are going to make that inequality happy. But remember, it's Thanksgiving dinner. I need ham and turkey to both be true. Otherwise, I'm going to throw a fit, and I don't want to do that and embarrass myself. So what I'm looking for is the overlap. That's the only piece of the graph that I need to see, is where both of these two graphs overlap. And that's my answer for the graph. On the other hand, an OR problem is really easy to spot. It has the word OR in the middle, and it always will. No big deal. What I want to do when I'm graphing this, I have two inequalities already. I'm going to do that first one in green, this second one in red. And I want to graph both of those inequalities by themselves, and then the answer is just going to be ham or turkey. Okay? It's going to be one or the other. It'll make you happy. So let's do the first one. X is less than negative 1. Okay, well, here is 0. 0 is not less than negative 1. So 0 is to the right of my circle. That means, and it didn't work. So what that implies is that all the numbers to the left of negative 1 will work. So that's how I shaded that piece. And now for my second inequality, I want all the numbers that are bigger than or equal to positive 2. Again, positive 2 is right here. I want to pick a test point. I like to use 0. 0 is not bigger than positive 2, so 0 is to the left. Since it didn't work, that must mean that all the numbers to the right of positive 2 will work. Okay? And for my final answer, what I would actually turn in on my paper is this graph up here in blue. Again, it's OR. Ham or turkey makes me happy. This down here was just scratch work. Now that we know the basics, and you might have already known it from a previous class, we're ready to try an example on our own. So first off, we're trying to solve negative 2 is less than or equal to 3t minus 8, which is also less than or equal to 10. Well, our variable is in the middle of two inequality symbols. So what that means is, automatically off the bat, this is an AND problem. So when we go to graph our final answer, we're going to be looking for that overlap, if there is any overlap. There might not be, but hopefully there is. And the very first step to make this a little bit easier for us is we want to split this up into two separate inequalities. So what I'm going to do is, my first inequality I'm going to do in green, my second inequality I'm going to do in blue. Alright, and we're just going to take our time with this. So I have negative 2 less than or equal to 3t minus 8. That's our first inequality. And then 3t minus 8 is less than or equal to 10. Okay, and we're just going to go through and solve each of these two inequalities now, just like we did in the previous video. Again, reverse order of operations, it's super important to remember. We need to get negative 8 over to the left-hand side. We do that by adding 8. Negative 8, positive 8 cancel out. 3t is just going to fall down. And the inequality symbol is just going to fall down. Now, negative 2 plus 8 is positive 6. And now we're ready to get t by itself. We're going to do that by dividing. So divide by 3 both sides. And I end up with 2 is less than or equal to t. Okay, well, I'm just going to pause there. That's one of my inequalities that I'm going to need, so I'm going to put a circle next to it. Okay, I'm done with that scratch work for now. Now, in my other inequality, I need to get t by itself again, and the steps are going to be pretty similar. I need to get negative 8 to the right-hand side, so I'm going to add 8. 3t falls down. Inequality symbol also falls down, and 10 plus 8 is 18. I need to get t by itself. The only way to do that is divide, because 3t, that means to multiply. Opposite of multiply is divide. Okay, so after dividing by 3 on both sides, I have t is less than or equal to 18 divided by 3, which is 6. Okay, so now I've solved both inequalities I needed. I'm now ready to graph. And I'm going to use the exact, put both of these on the same number line. Again, I just like to draw a sketch. We'll start off with 0 in the middle. Just kind of give me an idea of, to the left it's going to be negative, to the right it's going to be positive numbers. Okay? Now, I've got my variables by themselves. So what that means is I'm ready to put my circles down. I know I have a circle at positive 2, and I also have a circle at positive 6. Now, obviously, 2 and 6 are both bigger than 0, so they go to the right, but 6 is bigger than 2, so it needs to go farther right than positive 2. So be sure you draw your picture using just a little bit of common sense. All right, so for both of these inequality symbols, I have a line under it. So both numbers will get a closed circle. And now we're ready to start graphing. We're going to do this individually. So let's take care of the green inequality first. 2 is less than or equal to t, or you can read it t is bigger than or equal to 2. Now I suggest you always read it based on whatever side the variable is in. For instance, t is bigger than or equal to 2. I know in this particular problem, t is on the right-hand side. That's kind of counterintuitive. We're used to reading left to right no matter what we do. Always start off by reading whatever side the variable is on. T is bigger than or equal to 2. So again, I like to use 0 as my test point if I can. Is 0 bigger than or equal to 2? No. So 0 is to the left. It didn't work. What that means is all the numbers to the right of 2 will work. Okay, so I'm shading for the green inequality over to the right. Now, I want to look at the blue inequality. T is less than or equal to 6. Again, I use 0 as my test point. 0 is less than or equal to 6. 0 is to the left of 6, and it did work. So that means all the other numbers to the left of 6 will work. Okay, so I shade that way. Now for my final answer, which I'm going to do in red, all I care about is where this overlap is. And the overlap is between 2 and 6. So that piece of the graph is my final answer. And that's pretty much it for compound inequalities. Okay, just the key is split them up into two separate inequalities and solve them each individually. And take your time. That's it.